Welcome to the Calculus B section. In this section, we'll be discussing exponential functions and their derivatives. So in prior, we have derived basic functions, trigonometric functions, and complex functions. However, what if we needed to derive the following? F of x is equal to a of x. Well, if we used our limit principles for the derivative, we can say that f prime of x is equal to the limit as h approaches 0 over ax plus h minus ax over h. Now, we can say that using our exponential principles, we know that ax times ah is equal to ax plus h minus ax over h. Now we can factor out an ax, leaving ax times ah minus 1 over h, and we know that using our limit principles, we can take that value outside of the limit, and it is now no longer affected by our h approaches 0. This means our derivative is going to be f prime of 0 times ax. So whatever this value or this limit approaches 0 times our original ax function. Now what this would look like if we were to have something along the lines of e, or another logarithmic function, we'd say that f of x is equal to e of x. And now the derivative of that is actually going to equal e to the x. Now this is because on our logarithmic function, our exponent, we're going to say that this is going to equate to 1. We take the derivative of this and multiply it by itself. So this is going to be 1 times e to the x, therefore there is no value that it is being multiplied by, so it is just itself. Now if we had the function f of x is equal to e2 to the x, we would say that this is equal to f prime of x, and we can say 2x prime times e to the 2x. So it's going to be 2e to the 2x. Now, this is similar for if we had something looking like e to the x squared. So we're just going to apply the same principles and say f prime of x is equal to the derivative of our exponent times the same value itself. So it's going to be 2x e to the x squared. Now, if we were to use something like a to the x, okay, we'll say f of x is equal to a to the x. Now, the derivative for this would look something along the lines of f prime of x is going to equal a to the x ln a for our normal exponential function. So if we were to say f of x is equal to a4 of x, we would get something along the lines of f prime of x is equal to 4a to the x ln 4a. So I hope that helps you understand exponential derivatives and their functions a little bit more. I hope that helps. There's a bunch of problems on their website. Thank you.